Welcome to Grade 8 tutorial class for Quarter 1, Module 2. And this is Teacher Francisco, your math facilitator for the school year 2021 and 2022. Adding or subtracting similar rational algebraic expressions. For today's video, we will be adding or subtracting rational algebraic expressions with similar denominators. When we say similar denominators, they have the same or common denominator. In this lesson, you're going to add or subtract RAE with similar denominator. But before that, let's have a short review on how to add or subtract fractions. Number 1, 3/5 plus 7/5. So since we have a common denominator, we will copy 5, then add the numerators. 3 plus 5, that is equal to 10. So since this one can be simplified, so the final answer is 2, because 10 divided by 5 is 2. Now for subtraction, 10/7 minus 2/7, the same denominator, copy, but we need to subtract the numerator. So 10 minus 2, that is equal to 8. So since this is what we call improper fractions, we need to change this one into mixed number, and that becomes 1/7. Let's have an example of adding or subtracting RAE. Number 1, 3x squared minus 2x minus 7 over x squared minus 9 plus negative 2x squared plus 3x plus 1 over x squared minus 9. So this is our given. So to add these rational algebraic expressions, since we have common denominators, we will copy. Then we need to add the two numerators. So bring down the first numerator and also bring down the second numerator, but we will write them inside the parentheses. The next, we're going to combine the similar terms. So 3x squared and negative 2x squared are similar terms. That's why we write those similar terms in one parenthesis. Plus, then another similar terms are negative 2x and positive 3x. They are similar because they have the same exponent, which is 1. Just like in the first pair, their exponents are 2. So to continue, plus this negative 7 and positive 1 are also similar terms as a constant. So that's why we separate them, negative 7 plus 1. Then we will simplify this one. What is 3x squared minus 2x squared? In subtracting similar terms, we will simply copy the x squared. That's why we have here x squared. Then 3 minus 2, that is 1. But we don't need to write 1. Okay, therefore the answer of the first parenthesis is x squared. Plus this negative 2x plus 3x, since we are adding different signs, negative and positive 3, so we will subtract 3 minus 2, that is also 1, but we don't need to write 1. Then copy the sign of the bigger number, positive 3, so that's why we have a positive. Then copy x. Then for the last parenthesis, negative 7 plus 1, that is negative 6. Now, this time we're going to apply the different factoring techniques so that we can cancel the common factor if these two polynomials have common factors. Now, for this one, x squared plus x minus 6, we will factor this one using the general quadratic trinomial. How? We're going to find the factors of negative 6 whose sum is positive 1, and the factors of negative 6 whose sum is positive 1, which is our middle term. They are positive 3 and negative 2. Why? Because when we multiply positive 3 and negative 2, the product is negative 6. But when we add these two numbers, the sum is positive 1. So substitute this, distribute this x squared in the two parentheses. Now for our denominator, x squared minus 9, we will apply difference of two squares. And the factors of this polynomial are quantity x plus 3 and x minus 3. How? Simply distribute this x squared, then get the square root of 9, or distribute 9, this one. So the factors of 9 are 3 and 3. 1 positive and 1 negative. But since they are common, we will cancel them out and copy the remaining expression. So therefore, the final answer is x minus 2 over x minus 3. Let's have example number 2. X squared plus 2x plus 5 over x squared minus 4x plus 4 minus 2x plus 9 over x squared minus 4x plus 4. So since we have common denominators, we will copy. So x squared minus 4x plus 4. But we need to subtract the two numerators. So copy or bring down the first numerator, but write them inside the parentheses, and also the second numerator, which is 2x plus 9, write them also inside the parentheses. In the rule of subtraction, or even in the rule of integers, when we add two numbers or two expressions, we should always change the sign of the subtrahend or the second expressions. So in this case, we will change the sign of 2x and positive 9. But we need to bring down first this x squared plus 2x plus 5, this one. Then, as I said earlier, change the sign of these two terms. Positive 2x will become negative 2x. Then positive 9 will become negative 9. Then copy the denominator, which is x squared minus 4x plus. Then we're going to combine similar terms. So since there is only one x squared, we will bring down x squared. But 2x, positive 2x, and negative 2x are similar terms. That's why we combine them in one parenthesis. And also positive 5 and negative 9, they are also similar terms. That's why we write them in another parenthesis and copy the denominator. So bring down x squared. Next, 2x minus 2x, that is 0. Then 5 minus 9, that is negative 4. Then copy again the denominator. But we need to factor these two polynomials. Why? Because if they have common factor, we will cancel them out. Let's try. X squared minus 4 can be factored using difference of two squares. How to factor this polynomial? We will distribute this x squared in the two parentheses and also the 4. So 2 and 2. Then 1 negative and 1 positive. To continue, to factor the denominator, x squared minus 4x plus 4, this can be factored using perfect square trinomial. Why? Because the first and the last terms are perfect squares, and the product of these two, of their square roots and twice of it, is our middle terms. So to factor this one, we will distribute again this x squared in the two parentheses, and 4, that is 2 and 2. But since our middle term is negative, so we have factors of 2 negatives. So since these two expressions are common, we will cancel them out and copy the the remaining expressions in the numerator, which is x plus 2. Then for the denominator, x minus 2. So therefore, the answer of problem number 2 is, or the difference of this rational algebra expression is x plus 2 over x minus 2.